All right, this video is going to talk a little bit about systems of equations, and we're going to talk about the method of solving them called elimination. But in order to talk about elimination and eliminating with linear equations, first we want to talk about possible linear equations and some required vocab that we're going to want to know. So again, possible linear combinations of equations or systems of equations can come out in one of three ways. Again, we're talking linear, so straight lines. First, we can expect two lines just to cross, right? And when we have two lines that just cross, as the graph over here at the left illustrates, we call that a consistent system because it has answers, but we also call it an independent system. There's exactly one answer, right? We get exactly one place where those two lines cross. An algebraic clue to that would be that you'll get an actual answer. You'll get just a single x and a single y. We'll get one simple solution, right? We could also have two parallel lines, such as the two in the middle of the screen here. They're inconsistent because there are no solutions. And again, what will happen when we solve by elimination with those two is that we'll get something impossible, like a 0 equals 4, right? 0 can't equal 4, therefore there weren't any answers. And then finally, we could have two lines that are actually the same line. They could cross everywhere, right? We might not realize it right away, just depending on how they're written. But again, two lines that cross everywhere, again, they're still consistent. And that might seem kind of weird because it seems like an awkward thing to have happen, right? We don't get just one answer. But again, remember, consistent just means it has at least one answer. If it's consistent and dependent, right? Independent means there's a single answer, right? For this one x, there was one independent y that happened. Dependent means depending upon which x you pick, you can still get an answer for y. There are infinitely many answers. And what will happen when we're solving by elimination for that is we'll get something like 0 equals 0. We'll get an infinitely many kind of answer, right? And let's go ahead and take a look at a couple examples of when that can happen. So first of all, let's solve by elimination. Elimination is a little different method. You may have seen substitution or graphing before. Elimination just says, hey, if you've got two equations or a system of equations, such as over here at the left, where you've got some variables that are sort of lined up, right? We've got our x's lined up here. We've got our y's in the middle there, equal to our constants. If we actually go and just add our equations together, well, x plus negative x is 0x, which means we've eliminated the x's, right? 0x doesn't really need to be written. But 3y plus 2y would be 5y, and 1 plus 4 is 5. And if we divide by 5 very quickly, y equals 1. And we have half of our answer. Again, we just need to plug that back in. So x plus 1 times 3 would be 3 equals 1, and x equals negative 2. So again, we get negative 2 comma 1 for a solution. Because we got an answer to that, again, the second part of our problem here, tell whether or not it's consistent or inconsistent. Well, I would say that it's definitely consistent. We got an answer, and it's independent, in fact. Consistent and independent because, again, it was a single answer. In the middle here, I'm going to go ahead and look at it and say, well, wait a minute, 3x and 6x isn't going to eliminate if I add them together, right? That would be 9x, and we get a 6y. I didn't eliminate either variable there. So that's not really helping us out. So what we need to do is adjust our equations so that when I add them together, I can eliminate a variable. So looking at our x's, I'm going to go ahead and just look at x here and say, well, if I could make 3 into negative 6, what if I multiplied by negative 2? Well, then 3x times negative 2 would be a negative 6x. And that way, when I add that to that second equation, my x's should disappear, right? I'm going to get a 0x again, which is what I wanted. Now, I didn't have to eliminate x. I could have done y as well. But you'll notice actually in this equation, when I multiply negative 2, I need to multiply the whole equation, right? Including the other side. So therefore, negative 2 times 2 would have been minus 4y. And negative 2 times 3 would be a negative 6. When I go to add my equation, I do get 0 on the left side. Both my x's and my y's, right, adding them together, 4y plus negative 4y, is it also going to disappear. But notice that 14 plus negative 6 is positive 8. And again, therefore, no solution there, right? Not going to be any solutions. If 0 equals 8, well, that's impossible. So there's no such y and x combo that's going to make this happen. Therefore, again, that's an inconsistent system. Let's do the same thing for this last set of equations. Again, I'm going to notice my x's are negative 3 and 9. I'm going to multiply that top equation by 3. So that makes for a negative 9x. It's also going to make for a positive 3y, which you'll notice immediately means I'm going to get 0. But notice I also got a 15, 3 times 5 up here, right? When I went ahead and distributed. And negative 15 plus 15 is 0. So that makes this infinitely many answers, and infinitely many solutions, or a consistent and dependent, right, answer. Now there's only infinitely many, right, because, kind of like on our other screen, there are answers on these lines, right? Again, it's not that any xy works. I can't just pick a point like 10, negative 10, or 10, positive 10, or anywhere out in the middle here. I need answers that are on my line. So even though there's infinitely many answers, we could still say they have to be on that line. So I can say on line, and I'm just going to grab the top equation. Only answers that make this equation true are going to make both equations true, right? So again, I need answers that still work, right? Infinitely many on the line, or you could even have solved for y there and said, in fact, let's go ahead and do that. Let's make it look a little bit better. On the line y equals 3x plus 5, right? The answers have to satisfy that equation or they wouldn't be solutions. Now, how can we use this kind of an idea? Well, here's a simple linear situation. A total of $39,000 is going to be invested in 2 stocks. So if we just said stock X and stock Y, we're going to invest $39,000 here. They're expected to pay 5.75%, right? Simple interest. So simple interest simply times X. We're also going to get 0.0625 or 6.25% interest on the other stock. And we know we're going to make 24,000, right? Oops, 2,400 make that in simple interest from the investments. How much should be invested in the 5.75 stock? So realize I want to find X on here. Well, this is a great time. If we want to find X, we'd like to get rid of Y. So what I'm going to do is I'm going to multiply that top equation by a negative 0.0625. Now I know that seems like a really weird number, but that's going to give me exactly what I'm looking for to get rid of that Y value, right? To get rid of that Y variable. And now I just need to multiply. So 39,000 times 0.0625. Well, I'm going to need my calculator for that. So 39,000 times 0.0625. And we get 2437.5. 2437.5. And don't forget that that was negative because we multiplied by a negative, so that when we add them up, right, we're going to get a good number here. Negative 0.005x. My y values are gone, and negative 37.5 over here. Let's divide by our negative 0.005. And we'll find out that x equals, and I'm just going to go ahead and write my number over here. So negative 37.5. Oops, clear there. Negative 37.5. Let's make sure we use the negative and not the minus sign, right? Divided by negative 0.005. And we get an answer of $7,500. Oops. Little writing error there. $7,500. And again, we could go back and find the Y value as well. It just depends on how they word the question. But hey, if they only want one of the stocks, why not go directly to it, right? Elimination is great for that. Eliminate what you don't want, solve for what you do. One more good example of where we can use this, again, is solving kind of messier equations like this. Now, this one might not look very linear, but a good example of how we can sort of adjust equations. If I don't like the decimals in this second equation, why don't we just multiply the whole equation by 10? Right? That would make this simply x minus 2y equals 5, right? So that's a great way to sort of adjust our equations. In the same way, well, hey, if I don't like the fractions on top here, we want to get rid of that 2 and 3. Why not multiply by 6? Again, anything that's a half times 6 is really just going to be times 3. So I'm going to say 3 is going to get multiplied by negative x minus 3 up here. Again, this 3 here is going to divide into 6 twice. So it's going to be a 2 times our y plus 2. And again, don't forget to multiply that 15 as well. So that comes out to a simple 90. Now we're going to have to clean that one up a little bit, only because we've got sort of a lot of distributing going on. But still a good chance. Notice we just have a simple x and y to get a fairly good, nice equation here. So again, I'm going to write this one down below here. Let's go ahead and do it in blue. And we've got a negative 3x. I've got a negative 2y. And very simply, if I take negative 9 makes negative 13, I'm going to add that to the other side. Let's call it 103. Well, we've got a negative 2y and a positive 2y. So at the same time, I'm going to go ahead and multiply by negative 1. Right? Make that plus, plus, and negative. And therefore we get a 4x and a negative 98, which is going to simply give us a negative, right, 24.5 for x. Then we can go back and get the y values. Again, I'm going to go ahead and grab this red equation here, just because negative 24.5 minus 2y equals 5 looks like probably the simplest of all the equations to kind of go ahead and solve for. So negative 2y equals, I'm going to add and divide 29.5 divided by 2. So that's going to be, what, 14.75. And don't lose that negative. Again, if we can get those into simpler linear equations, right, where we don't have those fractions and decimals going on, sometimes that's a very helpful process. If you have any questions about solving via the elimination method or working with application problems, make sure you talk to your teacher. Otherwise, have a great day.